Hey everyone, so in this lesson we're going to review volume of composite solids. So before we get into composite solids, I want to first review the formulas for all the 3D shapes we went over last week. Okay, so the first one is volume of a rectangular prism. So again, in general for a prism, volume is area of the base times the height. Okay, so capital B always represents area of the base. And then since we're dealing with a rectangular prism, we know that the area of a rectangle is length times width. So I can replace capital B with length times width. Okay. Next one is a triangular prism. So in a triangular prism, the base is a triangle. So here we would replace capital B with the area of a triangle, which is 1/2 times the base times the height. Okay, so here's the base of my triangle. And I'm going to call the height of the triangle, we're going to call that H1. All right, and then this way, so we don't get confused, I'm going to call the height of the prism H2. Okay, so that would be the volume of a triangular prism. All right, volume of a cylinder is area of the base, and since it's a circle, the area of a circle is pi r squared times the height. For a cone, the volume is 1/3 pi r squared times the height. Okay, for a pyramid, the volume is 1/3 area of the base times the height. And a sphere, the volume is 4/3 pi r cubed. Okay, so you might want to have these formulas in front of you or be able to reference them as we go through the rest of the lesson. Okay, so to find the volume of a composite solid like the one shown here, you're going to find the volume of each part and then just add the parts together. Okay. So here it says find to the nearest hundredth the volume of the given composite solid. All right, so you'll notice that this solid is made up of a cone. All right, and then it's also made up of a hemisphere, which is half of a sphere. All right, so I'm going to start with the cone first. All right, and you'll notice here they give us the radius, but they don't give us the height. Right? Remember that the height of a cone is always measured from the vertex to the center of the base. So we don't have the height of the cone, so we're going to need to find that. All right, so hopefully you remember from the last lesson we did, to find the height of the cone, we're going to have to use Pythagorean theorem. So we're going to set this up as 6 squared plus h squared equals 10 squared. Okay, so 6 squared is 36, 10 squared is 100. If we subtract 36 on both sides, we get h squared is 64. So if I take the square root of both sides, the height of the cone is 8. Okay, so now I'm able to find the volume of the cone. So volume of a cone is 1/3 pi r squared times the height. So we got 1/3 times pi, our radius is 6, and our height is 8. Okay, and then from there I'm going to put the rest of this in the calculator. So we got alpha y equals to get our fraction. So 1/3 times pi times 6 squared times 8. Okay, so we get 301.5929 approximately. All right, so when you do problems like this, you don't round your answer until the very end. So when you're putting this in the calculator, don't clear your answer. All right, so on my paper, I usually copy 4 decimals. So we got 301.5929. Okay, then we also want to find the volume of the hemisphere. Okay, so again, a hemisphere is just half of a sphere. So the formula for volume of a sphere is 4/3 pi r cubed. And since we have a hemisphere, I'm just going to stick a 1/2 in front. Okay, so here this is going to be 1/2 times 4/3 times pi times 6 cubed. Okay, so we're going to go back to our calculator and we're going to type this in. So 1/2 times 4/3 times pi times 6 cubed. Okay, so we get the volume of the hemisphere is approximately 452.3893. Okay, and again, don't clear that answer from your calculator. Okay, so then to find the total volume, we're going to take the volume of the cone and add it to the volume of the hemisphere. Okay, so I'm going to go back to my calculator. And again, I don't want to round until the very end, so I want to copy both of these entire decimals. So I'm going to scroll up to the first answer we got for a volume of a cone. So notice how it's highlighted in the calculator. Hit enter, so the calculator copies that entire decimal, plus the volume of the hemisphere. So I'm going to copy that. So when we add that together to the nearest hundredth, we get 753.98. Okay, so again, to find the volume of a composite solid, you're finding the volume of the individual parts and then adding it all together. Okay, so another one that I think we can take a look at is number 4 on your worksheet. Okay, so number 4, you'll notice we have on top a square pyramid. Okay, and then on the bottom, we have a rectangular prism. Okay, so I'm going to find the volume of the square pyramid first. Okay, so volume of the pyramid is 1/3 area of the base times the height. And since our base is a square, we can replace capital B with side squared. Okay, so we get 1/3 times 7 squared, and then the height of our pyramid right over here is 10. Okay, so we're going to go to our calculator. set alpha y equals, so we got 1/3 times 7 squared times 10. Okay, so 490 divided by 3 is going to give us 163.33333. Okay, then we want to find the volume of the rectangular prism. Okay, so that's going to be area of the base times the height again. So in this case, the area of the base, since it's a square, is just going to be 7 squared. And the height is 15. Okay, so 7 squared is 49, times 15 is 735. Okay, so again, to get the total volume, we're going to take the volume of the square pyramid plus the volume of the rectangular prism. Okay, so I'm going to go back to my calculator. I'm going to take that previous answer for the volume of the square pyramid, add it to the volume of the rectangular prism, which was 735. So that gives us an answer of 898.33.